So this lesson is about finding the average rate of change of a function. And what I already have written for you here is sort of the definition. The average rate of change of a function f of x on the interval from a to b is that thing right there, f of b minus f of a over b minus a. In some sense, it's as simple as plugging into that. The majority of this video is going to be me doing 3 examples of that in different contexts. While I'm here in the beginning, I did want to mention really briefly conceptually what that's about. So in terms of average rate of change, so let's just say, for the sake of argument, that you're looking at some function like this, and this is f of x. And let's say that your a value is over here, and your b value is over here. When we're finding the average rate of change, especially as you guys prep for the AP exam, when you see rate of change, you should immediately be thinking that that rate of change means derivative, and that it also means slope. Right? So when we're saying the average rate of change, the average derivative, the average slope of f of x, this formula is effectively saying, and it should look like the slope formula, right? This is saying take the slope between the ending point and the beginning point. That slope right there is the average rate of change of the function. On average, that slope is the slope of the function. And so I'm going to make this drawing really messy here. But if you imagine taking all of these slopes and averaging them together, adding up all of those slopes and dividing by however many you did, you would find that this red slope is the average slope, the average rate of change of the function on the interval. So that's effectively what we're finding. We're saying, look, I understand this function is changing on the interval. I just want to know, on average, what is that rate of change? So like I said, I've got 3 examples of this. One is non-calculator, one is with calculator, one of them is kind of a different graph thing. So we'll look at those real quick. So the first one, find the average rate of change of that function on the interval between 0 and the natural log of 10. We just got a formula for this. It's really straightforward. We just do e to the b minus e to the a. I guess that's just a 0. All over b minus a. And then it's just kind of a matter of simplifying. And I did this one on purpose to give you an excuse to remember this. Remember, e to the natural log 10, the e and the natural log are inverse functions of one another. So you end up on the top with 10 minus e to the 0 is 1 over the natural log of 10. I end up with 9 over the natural log of 10. And that's it. That's the average rate of change of the function. No big deal. One more example. Actually, I guess it's 2 more examples. So use your calculator to find the average rate of change of this function on the interval between pi over 2 and pi. And I wanted to take this excuse just to talk to you about calculators a little bit. In the end, all you're going to need to do is f of pi minus f of pi over 2 divided by pi minus pi over 2. And so I hope you guys are getting used to this idea of it really makes sense to take this thing and plug it into y1 on your calculator. If you plug that into y1 on your calculator, then all you need to do is tell your calculator, do y1 of pi, and you can literally type that. I think you guys all know this, but you can type in y1 parentheses pi parentheses, and it'll do that. Then you do minus y1 of pi over 2. Hit enter and find out what that is. Divide all of that by pi minus pi over 2. If we throw all that at the calculator, we should hopefully find out, if I did my math right, if I did my calculator use right, this is 0.731. Yeah, just confirmed that's what I have. If you got something different, check and make sure you're in radian mode. Remember, we always want to be in radian mode when we're doing these things. So that's the average rate of change of the function. One last example. So given below is the graph of y equals f of x. I want us to find the average rate of change of the function on the interval from 1 to 5. Hopefully you guys are getting used to this idea of oh, look, they gave me a graph and they're asking things about that. They do that. I know a lot of your math up to this point pre-calculus has been, here's a function notation, do something with it. In calculus, a lot of times I'm not going to give you the function notation. You're going to be given a picture. I mean, this is a function. We shouldn't discriminate. We should be able to do things with this. So the average rate of change is supposed to be f of 5 minus f of 1 all over 5 minus 1. It shouldn't take you very long. I'd say pause the video. Make sure that you know how to read the graph and understand what this question is asking and work through it. So hopefully you found that f of 5 was negative 4 minus f of 1 is negative 2 over 5 minus 1. That's negative 2 over 4, which is negative 1/2. That's my average rate of change. Because I actually have a graph of this one, it's sort of fun. We can even say, look, here's the starting point, here's the ending point. If I look at connecting those two things with a straight line, the best I can do with a straight line, that's actually really not bad. This slope is indeed down 1 over 2. Down 1 over 2. It makes sense that this is the average rate of change of that function. So this video has really just covered the concept of computing average rate of change. The next one is going to be about something that we do with the average rate of change. So I'll see you there.